I made a simple audio mixer PCB project which was sponsored by PCB. Now I can combine multiple audio sources and easily connect them out to a set of speakers or a line input for recording. There's 3 stereo input channels, so the design is basically a 3-channel mixer using an op-amp that has been duplicated so that we can get a 3-channel left and 3-channel right mixer. The main inputs are 3.5mm stereo jacks, and the outputs of the op-amp go to a left and right pin of a 3.5mm jack as well. There's pin headers in parallel with those input jacks, so if we don't have audio cables, we can still just use things like DuPont jumpers to get audio in. So that way we can hook up things from a breadboard or another PCB, or from something like an MP3 player. I'm using an LM358 in a typical inverting summing amplifier configuration, using 10K resistors here to sum the inputs, and a feedback resistor to set the gain. I have it set here so each channel's maximum gain is 1/3, so clipping and distortion are minimized. If all 3 inputs are at max level, they won't as easily try to drive the output into extreme levels. I'm really only intending to use this for quick Workbench audio test hookups, so this configuration will work well for me, and I'm controlling the input levels with 10K trimmer pots. So I have an individual pot for left and right on all 3 channels. I'm using these 3362P style trimmer pots because they're small and convenient for a PCB, and trimmers are usually only rated for a lot less rotational adjustments than a regular potentiometer. But for my purposes here, I only plan to adjust these rarely, only if a signal is going to be way too strong or way too weak and I have to do something with it, rather than using these as everyday volume controls. The 3.5mm jacks I'm using are the PJ320D surface mount style. They're easy to obtain and I've used them in projects before, so I like them. And they're compact, so they fit easily on this board. The inputs and outputs have coupling capacitors to block DC offsets coming in and going out, and just pass audio. And being a single supply op-amp circuit, there's a voltage divider here to bias the op-amps between the positive rail and ground so the audio signal can pass through without clipping. I have it adjusted here where it worked well for the LM358 to give me the maximum input signal amplitude before distorting, because these are not rail-to-rail op-amps. So if I allow the signal to go too high, it'll clip before it gets to the 5-volt rail. So I just shift it down a little and then I can have a larger input. But these resistor values can be tweaked to change the bias if I use a different op-amp. So let's see how it works. Putting 2 test sine waves into the mixer, the inputs are showing on the 2 top scope traces, and the mixer levels are turned down, so the output signal is flat to start with on the bottom trace. As I adjust the input level pots up and down separately, I can get one signal to appear at the output, then the other, and finally I can get both of them mixed when I turn them both up. I can change the input waveform on the signal generator, changing the frequency or the wave shape, and see how it continues to mix them relatively well. Now testing the audio itself, hooking the output of the mixer up to the laptop's line in and using those sine waves as audio test tones, I can hear and record them just fine. Then adding an MP3 player, everything mixes well with no signs of distortion, and everything just sounds fine to me. So the mixer is doing what I expect and seems to be a good Workbench accessory. This isn't supposed to be top-of-the-line audio gear, and for what it is, I'm happy with the outcome and plan to use this extensively. Thanks to PCB for sponsoring the project, and thanks for watching.